Hey, it's Mr. Shrum, and I am back with the second part of the energy flow tutorial. We were about to talk about forms of energy. Last time we talked about kinetic potential energy, and now we're going to look at the forms of energy that energy can transform into. So we have electrical energy. When you switch on a lamp, electricity flows through the wires to light the bulb. Electrical energy is caused by the flow of electrons. And those are subatomic particles that, along with protons and neutrons, make up atoms. And an example of electrical energy is lightning. Think of lightning and electricity. Mechanical energy. Mechanical is very much what we've been talking about. Think of the moon orbiting the Earth. The moon has potential energy in its distance from Earth and the gravitational force between the moon and the Earth. It also has kinetic energy from its movement. Mechanical energy is a combination of potential energy and kinetic energy. Nuclear energy, that's the energy that holds the parts of atoms together. Sometimes nuclear from nucleus, meaning the same origin of words. Sometimes nuclear reactions are used in power plants as a source for generating electricity. Larger atoms are split into smaller atoms, releasing tremendous amounts of energy. Then we have radiant energy, radiant meaning light. When you switch on a flashlight, a beam of light appears. Light is a form of energy that's produced by the movement of photons in an atom. Photons are subatomic particles associated with light. Visible light, the light that you can see, is a small part of a large range of radiation. This range is called electromagnetic radiation, and the energy associated with that is called radiant energy. So electromagnetic radiation, radiant energy, think of light. Another popular one, sound energy, music that you hear through your speakers or your earphones, headphones, whatever you listen to. Sound energy is formed from the vibration of particles. Sound energy is actually a form of mechanical energy that we talked about earlier that is produced by the wave-like movement of particles. Thermal energy, if you sit next to a campfire on a cold night, on a chilly night, the heat of the fire keeps you warm. The burning wood gives off thermal energy. Thermal energy is the energy produced by a difference in temperature. It results in the movement of heat from a warmer body to a colder body. All right, so let me unanswer those questions, and then we can drag the tiles to the correct space. Well, produced by the vibration of particles, that is sound energy. Produced by the movement of electrons, think of electrons, electrical energy, fits there. There we go. Produced by the movement of heat. Heat, think thermal heat. Produced by the movement of photons. Photons is a particle of light. Light is electromagnetic radiation. Radiation, think radiant energy. That fits there. Submit, yay, we're correct. Let's go. Can energy change forms? All right, so picture yourself, you're exercising after rigorous activity like a game of basketball, you might be exhausted and out of breath, out of energy. Does this mean that your energy disappeared per se? No, that's not really how energy works. It doesn't just disappear. The total amount of energy in a system remains the same, but it can transform from one form to another. And when you play basketball, the chemical energy released by your body comes from the food you've eaten. So you eat food, your body breaks that down. There is chemical potential energy stored in that food. And then once you digest it, your body can use it as fuel to do work on the environment. The muscles of your hand transfer the energy to move the ball. So the flow of energy goes from food to you to the ball. Energy is not lost, it just changes forms. Chemical energy changes to kinetic energy in the muscles of your arm and hand. The kinetic energy transfers to the ball. As the ball bounces, it is pulled by gravity. The ball moves up and slows down as kinetic energy changes to potential energy. If you keep dribbling the ball, your muscles will soon tire because your chemical energy fades. And a good rest and nutritious food will ensure that you are ready for another day on the basketball court. And if you remember the law of conservation of energy, that states that the total energy of a closed system remains constant. It remains the same. A closed system is a system that doesn't let any energy escape. Think back to that skateboarder simulation that we did last time. At the top of the ramp, that skateboarder's potential energy was at its maximum. And then the potential energy changes to kinetic energy that makes the skateboarder move down the ramp with some velocity. And then when he's climbing the other side, kinetic energy is transformed back into potential energy. The total energy of the closed system remains constant no matter what that skateboarder or what their position is. So here we have a diagram of a pendulum. The motion of a pendulum is similar to the motion of a skateboarder on a ramp because it goes up and down, up and down. So match the descriptions of the changes in potential energy and kinetic energy to the position of the pendulum. Potential energy increases and kinetic energy decreases. Potential energy decreases and kinetic energy increases. So as it raises, the potential energy gets higher and the kinetic energy gets lower. But as it lowers and goes faster, the kinetic energy increases. And this mirrors the other side too. And the energy changes due to gravity. The stored potential energy is highest at the highest point, and it's moving the fastest at the lowest point, meaning that kinetic energy is the highest at the center. Transforming energy. To see wind blowing through the trees on a windy day is to see the wind's mechanical energy at work. Wind turbines use mechanical energy to generate electricity. Those large blades rotate because of the movement of air. The mechanical energy of the wind imparts kinetic energy to the fan blades. And those blades are connected to a generator that is lined with powerful magnets. The system works by spinning large coils of wire between the magnets. This movement converts the kinetic energy into electrical energy. This electrical energy is harnessed in the form of electricity, which is used to power homes and businesses. In this way, energy is transformed from one form to another and then to another until it produces something that's useful for us. Now we have an activity. You'll analyze a model and then answer questions based on the transformation of energy. The system modeled in the drawing shows how energy from the sun is used to power an electric car. The sun gives off solar energy. Those solar panels intake that solar energy, generates electrical energy. That goes into a battery, and that battery it contains chemical energy within that battery, and that allows the electrical car to move, the electric car. And that's that for that section. So next time we'll look at the spheres of Earth. I'm trying to make these videos a little shorter and break these up so it's a little easier to get through. And I hope you guys enjoy that. And until next time, see you later. Good luck with everything and have a great week. Bye-bye.